In presentation 11, I discuss some additional methods of identifying what you may have in your ore concentrates. This is an important step towards being able to calculate the amount of flux constituents to add to the charge. That is, the ingredients that will be mixed with the ore material or concentrate, which in turn forms the lead button and the slag. In this presentation, I am introducing that charge table and how it is used. I am Rob Boyko, Boyko Mineral Exploration, and welcome back. Once you know what your ore or concentrate constituents are, in the next 3 slides, these steps are meant to be followed in order to calculate the charge ingredients. Starting with step 1 will be the weighing out in grams the amount of ore or concentrate that you will be fusing. In most cases, this will be 0.5 of an assay ton. However, if you have impurities such as copper, nickel, etc., the amount weighed will be 0.25 of an assay ton. This calculation will be shown later in this presentation. A note here though, if potassium nitrate, that is niter, is required, and in many cases will be, not more than 28 grams will be used. For Class 1 and Class 3 ore types, the amount of sample weight can be 0.5 to 1.0 assay tons. Many textbooks will also state that it is possible to have an ore weighing 0.1 to 4.0 of an assay ton for the Class 1 and Class 3 ore types. I have talked about the silicate degree in an earlier presentation. For the Class 2 material having high sulfide content, a monosilicate degree will be used for the calculation. With impurities, a subsilicate degree is used. This equates to the use of the borax equivalent constant. For the Class 1 and 3 ore types, the bisilicate degree is used. This is step 2. Step 3 is the soda ash content, that is the sodium carbonate. The amount added to the charge will be the same as the ore that is to be fused. This is the same for all ore types, whether it being Class 1, 2, or 3. Step 4 is a big one. The more impurities you have, the more litharge will be needed to fuse the gangue material. The 30 grams is needed for the lead button. Additional lead oxide will be needed to form the slag. If a high sulfide ore that does not contain impurities, 30 grams plus 2 times the ore weight is needed. That would equate, for a 15-gram sample, 60 grams of lead oxide. Notice the table. For the Class 1 and Class 3 ores, the requirement specifies ore weight. But for the Class 2 ores, if you have contaminants, it changes to contaminant weight. The table will tell you to use 30 times the copper weight in the ore plus 30 grams of lead oxide. In step 5, each base metal and flux constituent is calculated and added, then subtracting 1/3 for the borax. This is the same for all classes of ore. Step 6 is used to calculate the amount of borax required in the flux mixture. As noted in the previous slide, 1/3 of the silica is to be replaced. For the sulfide ore, Class 2 ores without impurities, a monosilicate degree is used. The borax equivalent is 1.2. For Class 2 ore that does contain impurities, a subsilicate degree is used, and if your ore contains a very high concentration of the impurities discussed, a sesquisilicate degree is used. The borax equivalent of 1.3 for a subsilicate degree is most common. Rarely is the sesquisilicate degree and associated equivalency of 1.5 is used. In step 7, the reducing or oxidizing powers are calculated. For the Class 2 ore, niter or flour will be needed for the button creation size required. But for the Class 1 and Class 3 ore, it will be simply flour that is needed. These calculations will be shown later in the next presentation. Step 8 is only applicable when fusing Class 2 ore. It does not apply to Class 1 and Class 3 ore type. For each gram of niter used, 4 grams of soda ash is added in order to create the sulfate layer which forms on top of the slag. In addition to, additional soda ash is added to flux any excess silica present in the ore to be fused. In this last step of this table, it deals with some special cases, and it's important to be familiar with. If you have ever tried panning concentrate that contains zinc and magnetite, you would have found it to be very difficult without using a magnet to pull out the magnetite. Zinc is very difficult to fuse. It requires a minimum amount, that is 10 grams of borax or more, to fuse the zinc. Here is an exception. Ores that contain your impurities such as copper, nickel, selenium, and tellurium, borax will not be used. 1/3 of the silica will not be replaced. The full amount of silica will be required and used. Anytime your ore contains arsenic, you must add a top layer of soda ash. The amount is the same as the weight of the arsenic in the ore. If you are dealing with bauxite, you will probably have a large concentration of aluminum oxides. Same with the arsenic. But instead of soda ash, you will need to add an equal amount of calcium oxide, or 5 grams of cryolite. Again, you do not flux, it is a top layer. In addition to the Class 2 ore that contains the impurities discussed already, a 12-gram top layer consisting of 4 parts soda ash, 2 parts borax, and 1 part silica must be added. A salt layer may also be added on top of the charge. This inhibits the boil over when large amounts of gases are expunged during fusion. It also produces a washing action on the sides of the crucible, thus reducing corrosion and facilitates in the collection of the precious metals. I have to emphasize the importance of downloading a free copy of the periodic table of the elements. This table is used to calculate the molar weights of the compounds used. It is a vital tool that is used consistently. To be able to calculate the weights of each compound used for the 12-gram cover layer listed in the 9th step of the table, the atomic weight of each element must be known. I have listed the elemental weight for each element as well as added them up to show the molecular weight of each flux compound. For the calculations of the cover layer, I listed the molecular weight of the entire mixture, which is needed in order to calculate the weight of each flux material in the mixture. Once the weight of each item is calculated, the results can be added up to confirm the required amount. As 12 grams of this mixture is required, 4 parts of soda ash calculates out to 5.74 grams. 1 part equals 1 mole, which equals 106 grams. Borax equals 5.54 and silica 0.81 grams. Adding them up verifies the required amount of 12.0 grams of material. In this edited video presentation, I introduced you to the charge table. This table is designed to be followed step by step for the Class 2 ores on one side and the Class 1 and 3 ores on the other. By following these steps, the resulting product should be an ideal slag containing all the gangue material and a lead button of the required size containing all the precious metals. In the next presentation, I will be giving an example of the calculations and some dialogue for your understanding of the sequence regarding the Class 2 ore material. The result will be a summary of the quantity of constituents that will be mixed with the ore or concentrate to form the charge, as well as any top layer to be added to the top of the charge. I encourage you to download a copy of this presentation as it will be a handy reference going forward. As always, if you liked or found this presentation to be helpful, or if you know of someone that may benefit from this presentation, please give it a thumbs up, a like, and a share. That would be my greatest reward. I am Rob Boyko, Boyko Mineral Exploration, and I thank you for watching.